multiple ways of interacting with a smart contract using the CLI. But what if you don't have access to the CLI? Or maybe you don't want to use it for some reason? Well, you can always run functions from the Block Explorer. Here, I'm on Etherscan for the Ring B network. I have my contract, and you can see that I have some funds sitting here. I won't become rich today, maybe tomorrow. But here, in the contract section, we have some tabs that allow us to send transactions and make read or write operations. This simply means running functions on the contract. Read operations are really easy. Everything is public, so you don't have to connect any wallet or pay anything in order to get the values. This can be really useful when debugging your contract, because you can check any public value which is stored in the contract state. On the other hand, write operations require you to connect your wallet, as well as signing and sending real transactions to the blockchain. Here, we can do a lot of stuff, but let's mint a token and then withdraw the funds as an example. I'm using MetaMask in this case. So now I'm connected with a test wallet, which is not the contract owner, and the pre-sale is open, so I can decide to mint from here or from the dApp. It's the same. The function to be run during a public sale is mint. Here, I have to specify the amount that I want to send as a payment, 0.07 ETH in this case, and also the number of tokens that I would like to mint, which is 1. I click on Write. I confirm the transaction on MetaMask, and I wait for a notification. Now, how can I withdraw the funds from the contract? We have a dedicated function for that, and it's called, guess what? Withdraw. Let's try to see what happens if I try to run it with the current wallet. The transaction is expected to fail, and that's correct. If we take a look at the code, we can see that this function has the only owner modifier. That ensures that it can't be run by anyone but the owner. So if I switch back to the main wallet and I connect it, now I can send the transaction again, and this time I'm able to run it without any problem. And once it's confirmed, the contract balance will be empty, and all the funds will be transferred to my wallet. Great! This same concept here can be applied to any other contract function. Some of these are defined by my own code, while others are inherited from the contracts that we are extending, like all the ones related to the ownership. For example, you can take a look at the documentation by OpenZeppelin about the ownable contract. It's important to know that you can do things like transferring the ownership or even renouncing to it, which means that nobody will ever be able to control the contract again. Now, let me show you a quick tip because a lot of users get confused about it. We saw that whenever we want to mint, we have to specify the amount of ETH we want to send along with the transaction. This value is conveniently converted from ETH to WEI by Etherscan, so that we don't have to do it manually. Each payable function has this feature, but that's an exception, not a rule. Any other argument except value for a payable function will expect an integer value expressed in the base unit. For example, on Ethereum it's WEI, not ETH. Let's say we want to update the token price. We go to the setCost function and we want to update the cost to 0.1 ETH, right? No! These would actually be rounded to 0 because this input field is expecting an integer value, in WEI. So, in order to input this kind of values, I suggest you going to the read section, open the cost value, and here you can find the unit converter. Don't ask me why this is not available in the other section. From this page, I can change the value to 0.1 and copy the WEI value. Now I can insert this value in the setCost function, and this will work as expected. I don't want you to give away all of your tokens for free by mistake. Now, as promised, I want to show you how to create a simple script to run a custom function with code. I already minted a token, just so we have something in the contract balance. And we can open Visual Studio Code. I would like to create a withdraw script, so a good starting point might be the reveal script, since it's quite simple. I call it 9_withdraw.ts, and I can also add the command to the package.json file. I copy the reveal line, and I update it. Small typo here, but now it's correct. Great! Now the code is not doing much. It's simply updating the prefix and revealing the collection. We can get rid of the first action because we just need to run one function. I run the withdraw function, and it's done. Let's test it out. I run yarn withdraw -- network, and I'm using truffle in this case. And now, if we go back to Etherscan, the contract balance is empty. So it worked. The reason why I didn't include the withdraw script in the project is because this action requires one single transaction, and I imagine anyone would check the balance on the Block Explorer before withdrawing. So at that point, you can do it directly from there. But anyway, here is how to create a custom script.